few weeks ago, I was going shopping and I walked by somebody and I noticed they were wearing this shirt. The first time I read it, I chuckled a little bit, thinking that, oh, that's kind of funny, I get it. But then I thought about it more and I realized that there are many people who actually genuinely believe this statement, that they don't use algebra in the real world. And not only does that make me a little frustrated as a teacher, it actually makes me a little scared that we are not teaching our students correctly what algebra really is. Because today we're going to be doing our first introduction to linear equations, which you've probably seen a little bit of before. But linear equations is the primary skill in algebra. And not only is it the skill that you will use more than any other in the real world, it's also the one that you already use every single day. Now, you might doubt me a little bit on that, but I'm going to prove to you why. So, yesterday at the store, I brought in $55. I needed to buy 3 items, which I've shown below. A new stapler, a giant bag of Jolly Ranchers, and then the I haven't used algebra once t-shirt. The question is, do I have enough money? And immediately, people will be like, well, this isn't really an equation. And my argument is it absolutely is. Now, you would not go to the store and write down, the actual linear equation. And then write it out on paper and solve it. No, that's ridiculous. But algebraic thinking, the process of taking a piece of information and using it to solve a question, is absolutely something that you use in the real world. And that is exactly the skill that we're going to be learning every single day in algebra this year. Now, for this equation, one of the things I really like about linear equations is that there is no one correct way to write it. This is one way to write what you're doing in the problem, but you could also write, 55 minus these numbers here. Let's see if I can move them without deleting everything. And then writing that equal to something. We could call it y in this case. That's also a linear equation, and it's also solving the exact same process. Now, to be mathematically correct, we'd have to get our orders of operations, but when we talk about linear equations, I don't want you to get stuck in thinking about this, because this is a linear equation, 3 plus x equals 10. But it's also an example of a problem that says you buy an item that's $3, you bought another item that's x dollars, you weren't paying attention, and you spent a total of 10. How much money did you spend? So as we're working on these problems, I want you to always think about linear equations as you're simply finding a missing value. 3 plus something equals 10. And now I'm really hoping that you notice that 3 plus 7 is equal to 10, which means that our x is equal to 7. Now, if you learned a specific strategy to solve linear equations, that's great, but I'm not going to cover it right away in the video, just in case some people haven't seen it before. But this is exactly what we're talking about when we're solving linear equations. So in this case, negative 8 plus something is equal to 13. Now, people frequently will think, oh, 8 plus 5, that's equal to 13, so this must be 5. But it's also important to check. Now, it's almost unreadable, but negative 8 plus 5, well, this is a negative, so this actually gives us negative 3 equals 13. That's a false statement, which means that y is not equal to 5. So negative 8 plus something has to be equal to 13. The strategy that you might have seen before is you think about the equal sign as cutting the equation in half, and we do the opposite of the number that's on the same side as the variable. So I would add 8 to both sides, which would give me 21. So therefore, 21 must be equal to y. Now, there's a million ways to solve equations, and right now, I'm not really focused on the method that you choose. We will get into that a lot more in the next unit, but for now, I want you to just know that when you're solving an equation, you're solving for a missing value, and to be able to do that in real-world situations. So we have negative 6 minus c is equal to negative 10. Now for each of these problems, I'm going to try to think of a different strategy to kind of explain it, but you do not have to use my exact strategy. Now for this one, I noticed that negative 6 is farther to the right on a number line than negative 10 is. If I think about a number line, negative 6 is right here. Negative 10 is to the left of it. Therefore, we have to be subtracting more to get that direction. Therefore, the number in the box must be a positive 4, because negative 6 minus 4 more is equal to negative 10. Therefore, c is equal to a positive 4. For the problem on the right, oops, there we go. Now we got some fractions involved. Same idea, though. Okay? So what I think about is I think about this piece here as one big box. Plus 6 is equal to 9. So I know that 3 plus 6 is equal to 9. So now the question becomes 1/3 of some number has to be equal to 3. And I'm hoping that you know that 1/3 of 9 is equal to 3. Therefore, x is equal to 3. And that's about as challenging as the math is going to get for this section. It's going to be a lot of real-world story problems where we then have to solve the equation. So it's the fourth quarter, and the China Clippers basketball team is down by 18 points. Hasn't been a good game so far, but we still have a chance. We do need to score 19 points to win. What's the smallest number of baskets we can make? So we're going to solve this without writing out the equation first, and then we are going to create the equation afterwards. So if you are not a basketball buff, there are two types of baskets. You have a 2-point basket. Each basket's worth 2 points. You also have a 3-point basket. Now, we probably are going to start with 3-point baskets because they get more points. So one basket is equal to 3 points. 2 baskets is equal to 6 points. 3 baskets is equal to 9. This pattern continues down. And all of a sudden we're at 21, and we are too big for the problem. We cannot score exactly 19 with just 3-point baskets. So what we're going to do is we're going to stop here at 15, and then we are going to finish up with extra 2-point baskets on the side, which means that we need 4 extra points. So one basket is equal to 2 points. 2 baskets is equal to 4. Therefore, we have now scored a total of 19. But we have to figure out how many baskets did we actually score in this process. We did 1, 2, 3, 4, 5 3-pointers. So that's 5 times 3. And then we added 2 2-point baskets, which gives us a total of 19. So that is, we scored 5 3-point baskets. Now you might be thinking, wow, why is Mr. Schmidt writing out a full sentence for this problem? And you'll be very excited to hear that for every single real-world story problem, you have to write out a full, complete sentence. Wow, that's awesome. You are welcome, everybody. And 2 2-point baskets. I almost lost my train of thought there. Okay? Now, down here, I will consider this as a mathematical sentence or an equation. Normally, you need a variable to be called an equation, but for problems like this, simply writing it out as a mathematical sentence could count as an equation unless I specifically said otherwise.